3, 2, 1.
Hello, everyone. Welcome to Improving's Lunch and Learn series. I'm Scott Thompson, and today we'll be talking about karate, more than just an API. I was mentioning to my producer earlier that I must have been hungry when I gave that subtitle with a kick of UI for extra BDD flavor. And if you're hungry, go ahead and munch. We're just going to talk here a little bit about karate. About myself first, I've been an improver since 2018. I moved back to my hometown and found improving here. I've been doing QE, quality engineering, quality testing, QA, whatever you want to call it, since about 2015. I was working for a company that had a lot of manual QA that was unfortunately the bottleneck given our sprint speed. And so I started delving into the automation, but I've been doing development since 1995. So I like to say on my business cards that I've been doing both development and QA since the same time, about 1995, because I was the one person wearing the many hats back then. So I would say, you want that in cornflower blue, right? But that's how I got here. And as far as karate goes, karate itself, written by Peter Thomas, he actually has a quote out there when he was talking with Jack Kinsella that cucumber has its uses. Cucumber being part of karate in the framework. Principle is a high-level analysis tool on large projects. And you can read through the rest of that quote, but what it boiled down to, he said in response to this, that yeah, that's bingo. I know that this will resonate with a lot of folks who've used some flavor of BDD at some point to write tests for an existing system. While wondering, wouldn't a plain old integration test suffice? If karate is a misuse of cucumber, that's fine. Karate makes sense, especially for platform teams, creating and maintaining web services, and where product involvement in acceptance testing is not the highest priority. And I worked with a client here recently that was using karate strictly for API testing, but we ran into some situations where maybe we needed to be thinking about the user interface as part of the integration tests as well. And the way that karate is written, it keeps itself simple. It doesn't repeat itself. If you look here on the left of the screen, you can see that these are both examples out of the karate framework. It actually shows that on the left here, we've got an API test for the dogs endpoint. Well, what are we going to do? We're creating and retrieving a dog. Given the path dogs on the demo base URL, when we expect a 200, and then we're going to match the response for at least an ID that we know and a name of Scooby. Now there's your given when then of cucumber, and that makes a lot of sense. It's easy to read, and that's part of why cucumber is being used. It's not the cucumber purist cucumber, but it allows you to not repeat yourself and to have similar nomenclature for a UI test over here on the right, where we're going to be trying to log into GitHub and then do a Google search. We're given a driver, and we're checking inputs for certain parameters, well, putting in parameters in this case. Then we're submitting a click, and we're going to match the HTML at this CSS selector and make sure it contains a certain amount of text. The idea is you want to be able to use similar nomenclature such that it's easy enough to present feature files like this to someone and say, here's what the endpoint may look like in an integration test, and here's what the user interface around it may look like. These aren't strictly identical examples, but you could see how if we were doing something with a user interface that was matching the output of an API integration test, we could test the integration layer separate from the user interface layer and focus the user interface layer on the way the data is presented as opposed to what the data is. This came out and was important while I was with one of my clients who was doing some medical API work. So are they really just integration tests? Well, yes and no, but they can also drive front-end and back-end logic. So how would your data drive a user interface? Think about if you had data at an endpoint that was talking about what needed to be displayed in the user interface, but how you present the user interface might have dictation of how the data is received, or the data being sent might dictate how the user interface displayed it. And when should that data drive the interface? Can you think of examples in any of your APIs and integration tests where you might have a requirement in the data that said, well, no, the user interface needs to display this data in a particular way? Would you chart that data if it made sense, or would you lay it out in a table, for example? But when should the user interface shape the data? Are there instances where you say, no, chart's not going to work here necessarily? You know, we might be able to use something like a high chart to display the data, but we're not really going to be consuming it. Our users aren't actually going to be needing to read that data from a chart perspective. It may make more sense to have it laid out in the table. Have something where someone can hide and filter rows and such like that. Maybe you have a requirement where you need both. So when I was working with a particular client in the healthcare industry, one of the things that the new healthcare federal standard for health information, FHIR, Federal Health Information Resource, is now one of the standards being pushed, was around the name. So a user interface could very well, more often than not, is designed for like a first, middle, last name situation. But this FHIR standard actually says, wait a minute, you've got more than one name depending on cultural background. What if you had a traditionally Hispanic name that had 4 names in it? I know my daughter, for example, her first name is 2 words split into 2, Emma Grace, not run together. I put a space in there so that she could grow up and call herself Emma if she wanted to. But the idea is that the standard is defining that it's not just a first, middle, and last name. Matter of fact, it doesn't even have a number of names available. There's a given name that might be your first name, but otherwise there are family names that are included. Multiple last names, 2 middle names, however you want to put it. Either way, the user interface had to be redesigned in order to display the dictated, data dictated, say that 5 times, display the data dictated format. First, middle, and last didn't necessarily apply. First and in number of family names is what was the best for the user interface to best drive updating the data. Another example of how the data would drive the interface was a situation with gender. So this FHIR standard specifically defines, male and female, other and unknown. So our user interface for entering patient information was designed strictly for male and female. Now, where did the disconnect happen? Couldn't tell you specifically, but the point is there's data-driven design of the user interface that called out the fact that the gender dropdown was only binary and only had male and female. The legal ramifications, I'm sure you could imagine, of not supporting the FHIR standard, that was part of the entire client's drive, was to be able to say, we've got this standard done. All of our partners who are going to be using our data, our APIs, are going to need to understand that we have, for the FHIR standard, 4 entries for a gender. And if they were designing their own patient portals, that would have to be something that they would take into account, or they would be liable for not taking that data into account. That last point, what constitutes a properly supported user interface? Accessibility is something huge when it comes to a user interface. Are there portions of data in your API or your integration layers that are dictating a user interface that is not compliant? How do you manage those differences between what your data requirement is, what the business requirement from a legal standpoint, as well as just a user-driven standpoint, as well as the user interface itself, the capabilities and possibilities of that interface. And then you've got the aspect of the business logic that exists inside of the application layers for APIs and the integration into user interface. Again, with the client where we were working with drug information for this FHIR standard, there was a lot of back-end logic that touched, there were different APIs polling data for the one final user interface for listing out drugs. Some of them were private, where there was proprietary business rules being generated before we ever got to the data. And some were public, where it was generic drug information, but it was something that got merged together with roll-up logic on the API layer, where when you tried to go to a user interface and look for generic names, sometimes those generic names were wiped out during mapping. So you might have an endpoint on the back end before it's actually munged together with the API that was saying that I have a display name of atorvastatin. That's one I take. So there's your generic name, but you might have a brand name on top of it that during your mapping of these various disparate drug sources of information, you lose that display name. So the roll-up logic would actually wipe out the ability to be able to search for the atorvastatin name. There were several examples where issues with the API, even for user acceptance testing, we were actually presenting our APIs for UAT to large pharmaceutical and insurance companies. We would end up having errors come out of our UAT testing around the fact that they couldn't find their generic drug name or they couldn't find their brand name because the roll-up logic mapping was wiping out that information. And then when we're talking about insurance companies and the plans that were covered, the same kind of situation would happen. Back-end logic might duplicate plan codes, but what was happening was the only thing that was changed was the covered region in name only. So the roll-up logic was misidentifying valid coverage because the plan code wasn't necessarily for their specific region. The plan code may have been for another region, or the name might be covering another region, and the plan code they got back was only returning one region's name only. So when they went to look for a plan where they were covered in their region, they would get confusing results back as to what plan code was covered, and selection was problematic. So these are just a few examples out of, I'm sure, many examples you can think of where API logic and roll-up logic and back-end mappings and things like that might change the perception of the integrated output of an API response, whereas the user interface would be mapped to something that, from a user's perspective, would be problematic. Let's get ahead a little bit there. What I want to do now is take a look at some of the code that exists in the actual Karate framework. This is an example of an API feature, and you can see we're defining a URL. It's a base URL, and we're given a path to the API. We're adding a request to it, posting that request, then checking the status and trying to match the response with what we're looking for. In this case, a specific number, ID, and a name. See, there are several different examples. We're going to go ahead and define that ID. Then we're actually going to go back and say, hey, well, let's look up. Let's pull out this particular response and make sure, again, that we're doing a search by ID and we're finding the correct response. When we get all dogs, we go out and get the path. We want to make sure, oh, that's a duplication. Ah, this was a creation, we're posting. Very good. Now that we know that we've got Scooby, we can go and find Scooby. While not the same interface for that API, notice we've got very similar nomenclature, like my slide was discussing before. Don't repeat yourself. This is an opportunity to say, we're going to go out to GitHub and log in. We're looking for an input with a particular selector. We're going to put in some information. There's our password input. We're going to submit that. And in the response, make sure that we have an incorrect username or password in that response. So when we have this integration layer and UI layer, one of the advantages that Karate allows is that we keep working within the same framework such that we can focus testing on the API layer, much like the examples that I discussed earlier. We can do API testing that says, go and find this particular drug by name. Submit or create a patient that has an unknown gender or has multiple names. Our request object, when we're posting, can actually put in the correct FHIR standard for, I've got a given name, then I've got multiple last names. The interface for a response from that same API doesn't need to have a specific call to that API in order to test the API. You don't need to use the user interface layer to say, well, okay, I need to make sure that when I go and request and I say do a search for a patient, if I look for the name Scott or McConnell, my middle name, in any of the API endpoints for name, be it given name or the multiple names, when I provide that, I don't need to write a user interface test to do that search against a live API. We want to split those concerns. We want to write specific tests that do all of this API testing, all of this data testing against the API, such that we don't have to generate and run and spin up and run a web interface, a user interface to do that testing. But at the same time, we know we need to map our results, our responses into a user interface. One of the things that I've suggested clients do is when building out a user interface test, either have a static response URL that would be similar to, so that you can map to a known good response. In other words, you could actually build up the JSON response for an API test. Again, similar to how you would go through and say, we know that we want to have this response and match this response here because that's a known good. So you could have the same response, but you don't want to run a slower user interface test, let alone an end-to-end test, just for the integration layer testing. If you want to test the API, run something quick like an API call. The thing that you would be doing from your user interface against the API, but without having, again, to spin up the user interface and type in and do all of those weights and things like that that might come from a user interface test. What you can do with this test is say, take this same response here. We know that we're going to get a response back that says this, but build out either through a proxy or something similar, the responses that you need. They could be absolutely static responses, much like this. In fact, Karate allows you to call in external JSON files as part of your response. You could build an integration level test that called the same response, the same expected response as the output for that API in the user interface. So if you're making a call in for, say, if we're doing a get by ID, and we want the response to be sure and come back and say, I've typed into my user interface the ID or the name for Scooby. And when I click submit for that search, or it's an autocomplete or something similar, and we're looking at a grid of dogs coming back, as you enter that, you're not taking the time to call and respond to an API call. You want to make sure that your autocomplete, when it renders the output, has that item in the table. I know my current client I'm working with is doing a lot of pipeline testing, and there's live telemetry for sensors on their pipelines. And that creates a whole world of opportunity to be able to say, what can we do under the circumstance where we have a user interface that is taking live telemetry and needing to create a dashboard that says, hey, you've got a pressure change here that's outside of a threshold of rate of change, and we need to create an alarm. Imagine if you had a backend that, while not the API, was an AI-based, machine-learned set of chaotic responses, such that you may have a test against the API that says, well, when I make this request or when I'm looking for a particular sensor output, I know that I'm going to expect this in the API response. One of the things it's done is there's calculations of some of those thresholds for the pipeline that are being done in one of those middle tier layers, such that the calculation is not the raw data. So that's where you would be using an integration test against the API to say, now I know that this calculation for the business layer is going to be doing some kind of manipulation of the data, taking it raw, doing some time-based threshold testing, calculating over time to see if there's an average rate of change that might indicate a problem, but it's calculated. If you have an integration test that just works strictly on the production of those business logic differences and changes, then you can make sure that the business logic itself works. On the user interface side, rather than taking the time to do all of these calculations and check to see whether or not those calculations are correct, some of these calculations might take 10 to 20 to 30 to 40 minutes, depending on how much data is being pulled in for this dashboard to do some testing. So what you would do then is to be able to have something like a machine learned or an AI chaotic testing to throw out, hey, in this particular response, what we're going to do is, as someone zooms in or out of a particular time frame on the user interface, instead of doing all these calculations, we've got a known set of changes, rates of change that should trigger these thresholds. So you might have an API on the back end that randomly spits out some of these chaotic possibilities. You have a pressure drop on a riser, such that that looks like something you might want to alarm against. This way, the user interface isn't having to do or wait for all of these calculations. Of course, there are times that you want to be able to do testing such that you want to make sure that the user interface doesn't time out after a certain amount of time, weights and things like that that you would be doing, but those can be artificially created as well. This way, the user interface is not relying on a working API, and you can always test the API separate from what the user interface should be doing with the responses of the API. You could throw those chaotic things in there and say, we know that under certain circumstances, we might have a rate of change. Let's play those circumstances out on a charted user interface. Take a high charts and you generate SVG or something for it. That's another opportunity to where, instead of going and getting live data and you've got a chart available, you know that the known good API output might have charting that looks odd under certain circumstances. And when you zoom into or out of that data, you want to take a snapshot of that data, but because it's live data on the API itself, you might not be able to roll that data back. You want to be able to check it instantly and say, look, this particular rate of change is somewhere outside of our threshold. Let's zoom into it and not lose it, but let's be able to maintain the same response set. So there's a lot of opportunity with Karate to be able to do some of the basic style UI testing, such that if you had anything that was specifically strange or odd to do, or heavy level testing, even something like performance testing on an API or on a user interface, there would be opportunity to use UI specific testing, even screenshotting and things like that. But this marriage of API integration testing and UI testing within the Karate framework itself is something that allows you to specify UI testing separate from API testing and be able to do something where you have an integrated test that you can check on all of these business logic and business logic scenarios and back-end changes and mappings and things like that that I mentioned earlier from a from an API perspective, as opposed to a user interface perspective. Going back to gender drop down as well as naming drop down, you might be able to have multiple end-to-end tests that are putting in that fake data of, I'm going to put in or select an unknown gender, and I'm going to make sure that I put in names that would cause the user interface to say, hey, wait a minute, make sure you fill this out correctly. Now, I'm curious if anybody has any questions, and I'll give everybody now an opportunity to kind of formulate those, and we can start taking some questions.
We've got one question right off the bat. It says, where can people find the Karate website?
Let's see. Karate is on GitHub. So if you were to Google the Karate framework, I didn't have a browser up to show you specifically. Let's see. I thought I had a slide that had, nope, I don't have the URLs for the actual framework, but the entire documentation is on GitHub, and I can, let's see. If I pulled up a browser, I'm going to open a bunch of tabs. Let's see. Let me try that real quick. Let's see. There we go. And this is the GitHub right here. So all of the documentation is right here with it. They've actually done a very good job of documenting everything. You can see here everything that I was talking about using responses and such here. But that would be the best place. Here's an entire index of all of the documentation for that. The examples live on the GitHub as well. This code that I pulled up is actually from that GitHub. So they've got all of their examples listed here too. In fact, it's not the whole review, but it's in there. I'm curious if anybody in the audience has any questions around why wouldn't you do an end-to-end test, and what does it mean to separate out integration or API testing from user interface testing? I mean, that's kind of the meat of what I've been talking about, and how that pertains to a single framework that does both integration and user interface testing.
We can give them a minute to write out some more questions.
Absolutely. One aspect of quality assurance that I see bubbling up in the QA space in general is who writes automation code. There are some camps that say, well, it's the quality engineer. You know, they need to learn how to do all of this coding in order to best do their job. There are other camps that say, well, the developer should be contributing to those tests, because if you think about it, they're the ones who are writing code all the time anyway, and it's the quality engineer or quality person's role to think of the user and think of the way that a user might use a particular application in order to define some of that testing. Edge cases like. As a matter of fact, the conversation with one client about the dropdown was something that developers had developed the dropdown, and QA had not seen or interacted with the developers doing the user interface. They were mainly focused on the API side of things. And it wasn't until a QA looked at that user interface, they kind of took 2 and 2 and said, wait a minute, we're getting 5. We've got 4 genders on this API over here, but we've only got 2 genders on the dropdown. So the question of who writes the automation is more a matter of how focused is everyone on quality. If developers just write the code, they're not necessarily seeing the forest for the trees about a dropdown. If they're not aware of the fact that the user interface needs to take into account the fact that the business has an API written with 4 genders instead of just the 2 binary.
Not seeing any more questions come in. If anyone wants to access the recording of this presentation or get any more previous presentations from Improving, we post all of these on our YouTube channel. So if you just search Improving Enterprises, you can find us there.
Well, if we don't have any other questions, turns out you may actually have more of your lunchtime available than not.
All right, we can wrap up. Thanks so much for coming out and doing the presentation, Scott. Appreciate you.
Thank you for taking care of the audience for me as well.
Sure thing. All right, we'll see everybody later then.
Thank you.